Hello guys, welcome to my channel. In this video, we are going to perform the compaction factor test. Compaction factor test is basically performed to check the workability of concrete. There are number of apparatus or tests are used to determine the workability of concrete, and this is one of them to check the workability of concrete. And the workability is defined as the ease with which a concrete can be placed. So compaction factor apparatus is over here. As you can see over here, it comprises of two number of hoopers and a number of cylinder. In this video we are going to discuss the significance and use of this test, and apparatus and material required to perform this test, and what are the standard procedures according to Indian Standard Code, ACI and British Standard Code. We will perform this test as per standard procedure of ACI 211.3-75, and it was revised in 1987, and this formula will be used for compaction factor, that is weight of partially compacted concrete divided by weight of fully compacted concrete. So let's start our today's topic. First of all, what is significance and use of this test? Compaction factor test works on the principle of determining the degree of compaction achieved by a standard amount of work done by allowing the concrete to fall through a standard height. Now, this is the basic principle of this test, to allow the concrete to fall through a standard height, okay, to get compaction on its own weight. This is specially designed for laboratory use, but if the circumstances favors, it can also be used on the working site or field. Compaction factor test of concrete is more precise and sensitive than the concrete slump test. As I told you before, that a number of tests are performed to check the workability of concrete. One of them is slump test, VB test, flow table test, etc., and compaction factor test is one of them, and compaction factor test is more precise and sensitive than the concrete slump test. It is more favorable and useful for low workable concrete or dry concrete, okay, which is generally used when concrete is to be compacted by vibration. So that type of concrete which cannot be tested with other workability testing tests, compaction factor test is used when the concrete is of low workability or dry concrete and it has to be compacted by vibration. If we talk about the material and apparatus required for this test, first of all, obviously we have to prepare concrete mix. For this we will be needing water, ordinary Portland cement, coarse and fine aggregates. And apparatus will be compaction factor apparatus, trowel, shovel, tamping rod and electronic or physical balance. If we look at this apparatus, you can see over here it comprises of two hoopers, that is upper hooper and lower hooper, and dimensions are the upper side of a hooper is 260 millimeters and bottom is it is in conical shape, okay, and the depth of a hooper is 280 millimeters, and the difference between two hoopers is 200 millimeters, okay. As I told you before, the basic principle of this test is to allow the concrete to fall freely on its own weight. To allow the concrete to fall freely, there is a trap lock. As you can see over here, there is a trap lock and a trap door, okay. When this trap lock is turned clockwise or anti-clockwise, the door suddenly opens and the concrete that was filled in the upper hooper comes into the lower hooper on its own weight, and then it is again released through this trap door, which allow the concrete to fill up the cylinder, okay. We will discuss the procedure in upcoming slide, so just keep in mind the dimensions of this apparatus, okay. If we talk about the procedure, first of all we have to prepare a concrete of the desired ratio, as you can say 1:2:4, and the water cement ratio we used was 0.6, and place the concrete in the upper hooper with the help of a trowel or shovel. Hooper should be level with its berm. Open the trap door, allowing the concrete to flow into the lower hooper. For better understanding, keep watching that video. The practical we are performing and the video is on the right side of your screen. Keep watching that video as well. Immediately after the concrete has came to rest, struck off the concrete level with its berm. Now open the trap door of lower hooper, allowing the concrete flow into the cylinder. Now remove the excess concrete with the help of two floats, moving them from the edges across the top and pressing them with the top of concrete. Now wet the cylinder filled after wiping off the sides and base of the cylinder. This wet is called as partially compacted concrete. Okay, the concrete that was fallen freely from the upper hooper and then from the lower hooper and then came into the cylinder. Wet that cylinder along with that partially compacted concrete, and this will be called as partial wet or partially compacted concrete. Now refill the same concrete into the cylinder after emptying the cylinder in layers and then compacting the layers by giving the number 25 number of blows, and fill the cylinder in 6 layers to obtain the full compaction. Now again wet the cylinder and call this wet as fully compacted concrete. Now we got two wets, that is fully compacted concrete wet and partially compacted concrete wet. Now compaction factor can be obtained as weight of partially compacted concrete divided by weight of fully compacted concrete. The precautions must be taken into account that the difference occur in workability of concrete arising from the initial processes in the hydration of cement. As the hydration process starts, the water start evaporating or water start decreasing, which will affect the workability. So each batch therefore should be tested at constant time interval after mixing of concrete is completed. Sides and base of the cylinder must be wiped. The weight should be observed up to an accuracy of 10 grams. Now coming towards the result, as I mentioned the formula, compaction factor is equal to weight of partially compacted concrete and weight of fully compacted concrete. As you can see over here, this is the weight of fully compacted concrete with the weight of cylinder which was filled in 6 layers, and each layer was given 25 number of blows to get full compaction. Then there was partially compacted concrete, the concrete which was loose and come through the two hoopers and fallen freely and filled the cylinder on its own weight, that is called as partially compacted concrete. So as you can see over here, the weight of partially compacted is 18755 and fully compacted is 20572. So we get the compaction factor is equal to 0.91. Now what does this mean? What is 0.91? Let's see. If the compacting factor is 0.78, then it is considered as very low workable concrete, or this concrete has very low workability. If the compacting factor is 0.85, then it is considered as low workability of concrete. As you can see over here, 0.7 it is very low and 0.85 is low workability of concrete. Now if the compacting factor is 0.92, then it is considered as medium workability of concrete, and if the compacting factor is 0.95, then considered as high workability of concrete. In our case, the test we performed, our value was 0.91, which lies very close to this, and it should be considered as medium workability of concrete. So that's all for today. For more videos, you are requested to please subscribe the channel and press the bell icon to get video updates.